GCE O Level, Additional Mathematics, Lesson 1, Quadratic Equations. Hello everyone, my name is Dennis. This video is brought to you by Ace with Dennis. Now, learning can be smart, not hard. Don't forget to subscribe and press the bell notification button to stop missing out important updates from us. The learning objectives of these lessons are to determine the conditions for quadratic equations to have two distinct real roots, two equal roots, or no real roots. To determine the conditions for ax squared plus bx plus c to be always positive or always negative. To understand the relationship between the roots and coefficients of the quadratic equation ax squared plus bx plus c equals to 0. To form a quadratic equation when its roots are given. Let's recall how to solve quadratic equation. Let's say, solve the quadratic equation. Method 1. Factorization method. The equation is 3x squared minus 5x plus 2 equal to 0. To solve this equation, we can draw this factorization table and think about what are the two numbers multiplied together, we get 3x squared, and for this case is 3x times x, we get 3x squared. Then we also think about what are the two numbers multiplied together, I get a positive 2. For this case is negative 2 times negative 1, I get positive 2. Then we cross multiply the numbers, 3x times negative 1, I get negative 3x, x times negative 2, I get negative 2x, and I add these two numbers together, I get negative 5x. Therefore, the factors for this equation is 3x minus 2 and x minus 1. Hence, 3x minus 2 equal to 0, or x minus 1 equal to 0, x equals to 2 over 3, or x equals to 1. Method 2. Completing the square method. We know that x plus b squared equals x squared plus 2bx plus b squared. We can rearrange the formula and it becomes x squared plus 2bx equals x plus b squared minus b squared. And we can take note on the terms consisting b. The left-hand side term with b is 2 times the terms with b at the right-hand side. So that means the left-hand side is 2b, the right-hand side is b. If the left-hand side is b, then the right-hand side will be b over 2. Therefore, we can rewrite the formula and it will becomes x squared plus bx equals x plus b over 2 square minus b over 2 square. Now, let's apply this formula into the equation. 3x squared minus 5x plus 2 equal to 0. We need to make the coefficient of x squared to be 1 by dividing 3 for both sides. Therefore, it becomes x squared minus 5 over 3x plus 2 over 3 equal to 0. We can apply the formula at these two terms. And the b will be negative 5 over 3. When b over 2, it will be negative 5 over 6. Therefore, it becomes x minus 5 over 6 square minus negative 5 over 6 square plus 2 over 3 equal to 0. Take note on these two terms and don't expand it, because if you expand it, you'll get back the same thing. Next, we can sum the constant terms together and put them at right hand side. Then I square root the number, it becomes x minus 5 over 6 equals to 1 over 6, or x minus 5 over 6 equals to negative 1 over 6. Therefore, x equals to 1, or x equals to 2 over 3. Method 3. Quadratic Method. From the quadratic general equation, ax squared plus bx plus c equal to 0, we can apply similar concept with completing the square, where it will become x squared plus b over a, x plus c over a equal to 0, and x plus b over 2a square minus b over 2a square plus c over a equal to 0. We can continue to rearrange the equation and make x the subject. It will become x equals negative b plus minus square root of b squared minus 4ac over 2a. And this is the formula that we can use to solve the quadratic equation. So we know that the general quadratic equation is ax squared plus bx plus c equals to 0. And our equation is 3x squared minus 5x plus 2 equal to 0. Hence, a is 3, b is negative 5, and c is 2. So the formula is x equal negative b plus minus square root of b squared minus 4ac over 2a. By substituting the values inside the formula, we get x equals to 5 plus 1 over 6, or x equals 5 minus 1 over 6, and the answer is x equals to 1, or x equals to 2 over 3. We know that x equals to negative b plus minus square root of b squared minus 4ac over 2a. Now, when we want to solve this equation, 2x squared minus 3x plus 7 equals to 0. The a is 2, b is negative 3, c is 7. We substitute the values of a, b, and c into the formula, and we found that the x equals to 3 plus minus square root of negative 47 over 4. Since square root of negative 47 is not a real number, we can say that the equation has no real roots. B squared minus 4ac is a discriminant. If b squared minus 4ac is greater than 0, the equation has two real and distinct roots. If b squared minus 4ac is equal to 0, the equation has two real and equal roots. If b squared minus 4ac is less than 0, the equation has no real roots. Hence, if b squared minus 4ac is greater or equal to 0, the equation has real roots. Now, let's look at this example. Find the discriminant and hence determine the nature of the roots of each of the following equations. A. 5x squared plus 4x plus 6 equals to 0. B. X squared equals 8, x minus 2. C. 2x minus 1, x plus 3 equals 4. The solution for A is, first we need to identify the value of A, B, and C, which is A equals to 5, B is 4, C equals to 6. Then we can find the value of B squared minus 4AC, which is 4 squared minus 4 times 5 times 6, which will give us negative 104. And since b squared minus 4ac is less than 0, we can say that the equation has no real roots. For b, we need to expand and rearrange the formula. The equation becomes x squared minus 8x plus 16 equals to 0. A is 1, b is negative 8, c is 16. And the b squared minus 4ac will becomes negative 8 squared minus 4 times 1 times 16, and the answer is 0. Hence, we can say that since b squared minus 4ac is equal to 0, the equation has two real and equal roots. For c, we need to expand the brackets and rearrange the equation to be 2x squared plus 5x minus 7 equals to 0. A is 2, b is 5, c is negative 7. Then the b squared minus 4ac will be 5 squared minus 4 times 2 times negative 7, and it gives us 81. Since b squared minus 4ac is greater than 0, the equation has two real and distinct roots. Now, you can try this yourself. Find the discriminant and hence determine the nature of the roots of each of the following equations. A. X squared plus 12x plus 36 equals to 0. B. X squared equals 2, 3x plus 8. C. 3x minus 4, x minus 1 equals negative 5. You can pause the video and try to get the answer yourself. Now, the answer is this. Have you got the answer correct? Let's look at another example. The quadratic equation x squared minus kx plus k plus 3 equals 0 has two real and equal roots, where k is a constant. A. Find the possible values of k. B. Hence, for the smaller value of k found in A, find the roots of the equation. The solution for this example is, for A, from the given equation x squared minus kx plus k plus 3 equal to 0, we determine A equals to 1, B is negative k, and C is k plus 3. So, it is given that the equation has two real and equal roots. We can say that b squared minus 4ac is equal to 0, which will become negative k squared minus 4 times 1 times k plus 3 equal to 0. And it will become another quadratic equation, becomes k squared minus 4k minus 12 equals to 0. We can factorize, becomes k plus 2, k minus 6 equals 0, k equals to negative 2, or k is equals 6. For B, the smaller value of k is negative 2. Hence, the equation becomes x squared minus negative 2k plus negative 2 plus 3 equal to 0. And it becomes x squared plus 2x plus 1 equal to 0. Or x plus 1 squared equal to 0. The x is equal to negative 1. Now, you can try this example yourself. The quadratic equation 9x squared minus 4kx plus k plus 1 equal to 0 has two real and equal roots, where k is a constant. A. Find the possible values of k. B. Hence, for the larger value of k found in A, find the roots of the equation. You can pause the video and try to do it yourself. The answer for A is k equals to negative 3 over 4 or 3. B, x equals to 2 over 3. Do you get the answer correctly? Now, let's look at another example. If the equation 2x squared plus 5x minus bracket 3k plus 4 equal to 0 has two real and distinct roots, find the range of values of the constant k. The solution for this example is, from given equation 2x squared plus 5x minus bracket 3k plus 4 equal to 0, we can get a equals to 2, b is 5, c is negative 3k minus 4. Given that the equation has two real and distinct roots, therefore b squared minus 4ac is greater than 0. Substitute the value of a, b, and c, we will get 5 squared minus 4 times 2 times negative 3k minus 4 greater than 0. And solving this inequality, we get k is greater than negative 57 over 24. Now, you can try a similar question yourself. If the equation 3x squared plus 4x minus 2k plus 5 equal to 0 has no real roots, find the range of values of the constant k. You can pause the video and try to do it yourself. The answer is k is less than -3 and 1 over 6. Do you get the answer correctly? Let's discuss discriminant and quadratic graphs. From the general quadratic equation, y equals ax squared plus bx plus c, if b squared minus 4ac is greater than 0, we know that the equation has two real and distinct roots. So if we plot the graph, for a is greater than 0, we get this quadratic graph intersect at the x-intercept at two distinct points of alpha and beta. If the a is less than 0, the quadratic graph will also intersect the x-axis at two distinct points of alpha and beta. If b squared minus 4ac is equal to 0, we know that the equation has two real and equal roots. So this is the graph when a is greater than 0, where the graph intersects at one point, alpha is equal to beta. Similarly, when a is less than 0, the curve will bend up with intersection one point at the x-axis, where alpha equal to beta. If b squared minus 4ac is less than 0, the equation has no real roots. So this is how the graph will look like when a is greater than 0. The graph does not touch the x-axis. The graph is always positive. Or when a is less than 0, the graph will look like this, and it will never touch the x-axis. We can also say the graph is always negative. Let's look at one example related to discriminant and quadratic graphs. If the expression kx squared minus 2x plus 5 is always positive, where k is a constant, find the range of values of k. The solution is, from given expression kx squared minus 2x plus 5, we know the a is k, b is -2, and c is 5. Given the expression is always positive, where k is greater than 0, therefore b squared minus 4ac is less than 0, we substitute the values of a, b, and c, we get that k is greater than 1 over 5. So we combine these two inequality condition. When k is greater than 0, the arrow will point to the right starting from 0, and k is greater than 1 over 5, the arrow will point to the right from 1 over 5, and this is the region where these two arrows overlap each other. Therefore, we can make the conclusion that k is 1 over 5. Here is another example that you can try yourself. If the expression x squared minus 6x plus c is always positive, where c is a constant, find the range of values of c. You can pause the video and try to do it yourself. The answer for this example is c is greater than 9. Do you get the answer correctly? Relationships between the roots and the coefficients. Consider the equation 6x squared minus 7x minus 5 equals 0. We can solve the equation by factorizing it. It becomes 2x plus 1 times 3x minus 5 equals 0. And we get x equals negative half, or x equals 5 over 3. On the other hand, if the roots of an equation given is negative half and 5/3, we can reverse the steps to form a quadratic equation. Given x equals negative half or x equals 5/3, we can find the factors 2x equals negative 1 or 3x equals 5. 2x plus 1 equals 0 or 3x minus 5 equals 0. Hence, the factors are 2x plus 1 and 3x minus 5. From the quadratic equation, we get bracket 2x plus 1 bracket 3x minus 5 equals 0. Expand it, you get back to the original equation, which is 6x squared minus 7x minus 5 equals 0. Here is one example. Form a quadratic equation with integral coefficients such that its roots are 4/3 and negative 7. The solution for this example is, let x equals 4/3 or x equals negative 7. We reverse the process, it becomes 3x equals to 4 or x plus 7 equals to 0. 3x minus 4 equal to 0. Hence, the factors are 3x minus 4 and x plus 7. The quadratic equation is 3x minus 4 times x plus 7 equal to 0. Expanding it, it becomes 3x squared plus 17x minus 28 equals 0. Now, you can try this similar example yourself. Form a quadratic equation with integral coefficients such that its roots are 2/5 and negative 1. You can pause this video and try to do it yourself. So the solution for this example is, let x equals 2/5 or x equals negative 1. Hence, 5x equals 2, x plus 1 equals 0, 5x minus 2 equals 0, and the factors are 5x minus 2 and x plus 1. The quadratic equation is 5x minus 2, x plus 1 equal to 0. Expanding the equation, it becomes 5x squared plus 3x minus 2 equal to 0. Sum of roots and product of roots. Let alpha and beta are the roots. By the same approach, we can form the quadratic equation x minus alpha times x minus beta equals to 0. X squared minus alpha plus beta x plus alpha beta equal to 0. We can name this as the first equation. We also know the general quadratic equation as ax squared plus bx plus c equals to 0. Divide a for both sides. We get x squared plus b over ax plus c over a equals 0. We name this equation as the second equation. Equate the first and the second equation. We get x squared minus bracket alpha plus beta x plus alpha beta equals x squared plus b over ax plus c over a. We compare the coefficients. The first one is negative bracket alpha plus beta to b over a. Hence, negative alpha plus beta equals b over a. Simplify, it becomes alpha plus beta equals negative b over a. Next, we compare alpha beta to c over a. Hence, alpha times beta equals c over a. These two are important formulas related to sum of roots and product of roots. The first formula is the sum of the roots, and the second formula is the product of roots. Let's look at one example. Given that alpha and beta are the roots of the quadratic equation 5x squared minus 10x plus 3 equal to 0, find the value of each of the following: a. alpha plus beta, b, alpha times beta, c, alpha square plus beta square, d, 1 over alpha plus 1 plus 1 over beta plus 1. The solution is, from the equation, find x squared minus 10x plus 3 equal to 0, we know that a is 5, b is negative 10, c is 3. Hence, for a, alpha plus beta, it is equals to negative b over a. Substitute the values, it becomes negative bracket negative 10 over 5, and the answer is 2. For b, alpha times beta, it is equals c over a. Substituting the value, it becomes 3 over 5. For c, alpha square plus beta square, from the formula alpha plus beta square equals alpha square plus 2 alpha beta plus beta square, we make alpha square plus beta the subject, and it becomes alpha plus beta square minus 2 alpha beta. And we substitute the sum of the roots and the product of the roots, we get 2 square minus 2 bracket 3 over 5, and the answer is 14 over 5. For d, 1 over alpha plus 1 plus 1 over beta plus 1. We can make them to have the common denominator of alpha plus 1 times beta plus 1. Hence, the numerator becomes beta plus 1 plus alpha plus 1. Simplifying this equation, it will become alpha plus beta plus 2 over alpha beta plus alpha plus beta plus 1. And we substitute the sum of the roots and the product of the roots, it will be 2 plus 2 over 3 over 5 plus 2 plus 1. Simplify this fraction, we will get 10 over 9. Now, it's your turn to try this similar example yourself. Given that alpha and beta are the roots of the quadratic equation, 4x squared plus 6x minus 9 equals 0, find the value of each of the following: a, alpha plus beta, b, alpha beta, c, alpha plus 3 times beta plus 3, d, alpha over beta plus beta over alpha. You can pause the video and try to do it yourself. The answer for A is negative 3 over 2, B is negative 9 over 4, C is 9 over 4, and D is negative 3. Do you get the answers correctly? Let's look at this example. Given that alpha and beta are the roots of the quadratic equation x squared plus px plus q equal to 0, where p and q are constants and alpha is greater than beta, express the following in terms of p and q. A, alpha square beta plus beta square alpha. B, alpha minus beta. The solution for this example is, from the equation x squared plus px plus q equal to 0, we know that the A is 1, B is p, and C is q. Hence, the alpha plus beta equals negative b over a. We get negative p over 1 or negative p. Alpha times beta equals to c over a, which is q over 1 or q. So, the first expression A, alpha square beta plus beta square alpha, we can factorize alpha beta. It becomes alpha beta times alpha plus beta. Substitute it becomes negative p q. For B, we start from alpha minus beta square, which is equals to alpha square minus 2 alpha beta plus beta square, or alpha square plus beta square minus 2 alpha beta, or alpha plus beta square minus 4 alpha beta. Substitute the sum and the product roots, which is bracket negative p squared minus 4q, we get p squared minus 4q. And alpha minus beta will be square root of p squared minus 4q. Now, you can try this similar example yourself. Given that alpha and beta are the roots of the quadratic equation x squared minus mx plus n equal to 0, where m and n are constants and alpha is greater than beta, express the following in terms of m and n. A. Alpha cube beta square plus beta cube alpha square. B. Alpha square minus beta square. You can pause the video and try to do it yourself. The answer for A is mn square and B is m square root m square minus 4n. Do you get the answer correctly? Let's look at this example. If one of the roots of the equation 2x squared plus kx plus 25 equals 0 is twice the other, find the possible values of the constant k and the roots. The solution is, from the equation 2x squared plus kx plus 25 equals 0, we know that a is 2, b is k, and c is 25. The sum of the roots is alpha plus 2 alpha equals to negative BOA, because in the question it says one of the roots is twice the other. Therefore, 3 alpha equals negative k over 2. For the product of roots, it is alpha times 2 alpha equals c over a, which is 2 alpha square equals 25 over 2, or alpha square is 25 over 4. Alpha is plus minus square root of 25 over 4, which is alpha equals to 5 over 2, or alpha equals negative 5 over 2. We go back to the sum of roots. We get k is negative 6 alpha. When alpha equals 5 over 2, the k will be negative 6 times 5 over 2, which is negative 15. When alpha is negative 5 over 2, the k is negative 6 times negative 5 over 2, which is 15. So these are the possible values of the constant k. Now you can try this similar example yourself. If one of the roots of the equation x squared minus 8x plus k equal to 0 is 3 times the other, find the possible values of the constant k and the roots. You can pause the video and try to do it yourself. The answer is k equals to 12. The roots are 2 and 6. Do you get the answer correctly? If alpha and beta are the roots of a quadratic equation, then when forming the equation x equals alpha or x equals to beta, x minus alpha times x minus beta equal to 0, x squared minus alpha x minus beta x plus alpha beta equal to 0, x squared minus bracket alpha plus beta x plus alpha beta equal to 0, we get x squared minus sum of roots x plus product roots equal to 0. We can use this equation to form the new equation. Now let's look at this example. 5 minus square root of 3 is a root of a quadratic equation. Find the equation. The solution is, we know that x equals negative b plus minus square root of b squared minus 4ac over 2a. Alpha is negative b plus square root of b squared minus 2ac over 2a. and beta is negative b minus square root of b squared minus 4ac over 2a. If alpha is 5 minus square root of 3, then beta will be 5 plus square root of 3. Hence, alpha plus beta equals 5 minus square root of 3 plus 5 plus square root of 3, which will get 10. For alpha times beta, it is equals 5 minus square root of 3 times 5 plus square root of 3. We get 5 squared minus square root of 3 squared, which is 25 minus 3, and the answer is 22. So the equation is x squared minus 10x plus 22 equals to 0. Now you can try this example yourself. 7 plus square root of 2 is a root of a quadratic equation. Find the equation. You can pause the video and try to do it yourself. The answer is x squared minus 14x plus 47 is equal to 0. Do you get the answer correctly? This is another example. If alpha and beta are the roots of the equation 2x squared minus 5x minus 4 equal to 0, find the quadratic equation with the given roots alpha over beta and beta over alpha. The solution is, from the equation 2x squared minus 5x minus 4 equal to 0, we get a equals to 2, b equals negative 5, c is negative 4. Hence, alpha plus beta equals to negative b over a. We get negative 5 over 2. The answer is 5 over 2. Alpha times beta equals c over a. We get negative 4 over 2 or negative 2. Sum of new roots is alpha over beta plus beta over alpha, which we get alpha squared plus beta squared over alpha beta, or alpha plus beta squared minus 2 alpha beta over alpha beta. By substituting the sum and the product of roots values, we get 5 over 2 squared minus 2 times negative 2 over negative 2, and the answer is negative 41 over 8. The product of new roots, alpha over beta times beta over alpha, which is equal to 1. Hence, the new equation is x squared plus 41 over 8x plus 1 equal to 0, and we can multiply 8 for both sides, which we get 8x squared plus 41x plus 8 equal to 0. Now you can try this example yourself. If alpha and beta are the roots of the equation 3x squared plus 7x minus 1 equal to 0, find the quadratic equation with the given roots 2 alpha plus 5 and 2 beta plus 5. You can pause the video and try to do it yourself. The answer is 3x squared minus 16x plus 1 equal to 0. And that's all for this video. Thanks for watching. Do you have any thoughts, opinion, or experience to share? Write it down in the comments. We would love to hear from you. Do you like this video? Please don't forget to like and share to your friends. Until then, see you in the next video. Have a great day ahead.